All right. So welcome to the Database Cloud Service Office Hours this week. It's about the top of the hour, so I'm going to wait another minute or so. We've got about 20 participants. We'll let a few more come in. So give us about a minute and we'll start. Great. So again, welcome to this week's Database Cloud Service Office Hours. We're very fortunate to have Franck Pachot from DBI Services to speak to us today about features that you potentially lose when you move off the Oracle database. So very often in this series, we talk about new features, new capabilities. What we're doing here today is talking about things that have been in the database for quite a while, but make a huge difference to developers, to DBAs, and to people that are delivering services. So with that, I am just, and a couple of things here. Go to the next page. If you have any questions, please ask those in the chat, and we will be happy to answer them. We're either going to answer them at the end of the call, or if they're relevant to what Frank is discussing right at the moment, we'll answer them right away. But just shoot your questions into the Q&A. As you know, this series talks about, as I mentioned, new releases, new features. Things are very relevant to the database and app development that's tied to the database. We also do reviews of the basics of particular features, detailed competitive comparisons, etc. So if this sounds interesting to you, please subscribe to the Ask Tom channel. All right. And with that, I'm going to stop sharing and let Frank take over. Over to you, Frank.
Yeah. Hello, thank you. Let me find the screen that I want to share. Here it is. You can see my screen. I will have a few demos there, and we will start with the slides there. So, as mentioned, if you have any question, just ask them. We have time and we can go to topics further than what is on the slide. So ask question and then we will see if we answer it immediately or not. I'm Franck Pachot. I'm working in Switzerland at DBI Services as a consultant. I've been always working as a consultant and mostly on the Oracle database. And I have a few certifications. I wrote a few chapters of the multi-tenant book. The Oracle ACE program that you should know if you contribute in blogs, in conferences, anywhere about Oracle products, think about applying to the Oracle ACE program. It helps to share the knowledge and to communicate with people at Oracle, product managers. I'm working at DBI Services. We do consulting, we do also trainings with workshop, and we do them remotely as well. We have some customers we manage remotely with SLAs. We have most of our customers in Switzerland, but we also work in Europe and remotely with many other customers. We are Oracle partner. I will not list all the topics. We are specialists with the partnership. This is the main content for this presentation. So the idea was to take a few features in the idea that if you want to move from Oracle to another database, especially open source, because this is the trend, there are a few features that you may miss. and they may not be the features that we talk a lot today, because a lot of features that you use every day are there for years and years and years. And you will see that I will start with select, insert, update, because there are things exclusive in Oracle database that we use all the time with that. 19 features, that's probably too much, so I will go faster on some of them. But if you have questions, we will go deeper on them. So the main reason for this presentation is that I've seen a lot of people talking about new features in open source databases. For the right reason, they evolve a lot. MySQL, PostgreSQL are evolving a lot. They have a big community behind. But if you just look at people talking about it, usually we talk a lot about new features and we don't talk a lot about the old features, but our production databases maybe rely more on old features. And this is the idea, to counterbalance that with this presentation. On the screen, you can see the famous DB engine ranking, which rates databases by popularity. So first thing to say there, it is popularity. People talking about it in Google, on Stack Overflow, but that doesn't mean that those are the best databases, and it doesn't mean that they are the most secure for your data. Just people talk about it, and of course, when new feature comes, we talk about it. Second important thing, if you see this DB engine ranking, the scale is logarithmic, so it gives the impression that those, for example, PostgreSQL is near the big ones, Oracle, MySQL, and SQL Server. But this is a huge gap because this is a logarithmic scale. So actually, what looks like something slowly increasing is something exponential, and you know that nothing grows exponentially for a long time. There are kind of buzz behind new features. When I say new features, for example, when MySQL implements hash joins, just in the last release, everybody talks about it because everybody was waiting for this join method. And this is something that we have in Oracle for decades. Same with Postgres. Now Postgres start to have partitioning. This is something we have for a long time in Oracle. So the idea is to take the old features and not only the new ones. And we will start with the most simple, with select. Of course, every database can do a select, but Oracle has something that you cannot find in a lot of databases. You can select without locking anything, which means that you can read data even if people are doing massive ingestion in behind. And to illustrate that, I have a small demo. So my screen is split in two. In the bottom, I will open a session on the Scott Tiger schema with the old SQL Plus, and I will select from AMP. And because it's a small table, I will select and paginate it, like just a few rows by few rows, so that we can see what happens when the query is running.
Frank, can you screen share the? Can you switch the screen to your demo?
You cannot see the demo on the screen that is shared?
Not right now. I'm not sure.
Okay, then I stop the sharing and I reshare. That was probably because I shared the application and not the screen. This will be better.
I see. Sure. Yeah, yeah.
Yeah, perfect. Yeah. Only the PowerPoint was shared. Thank you. So in the bottom, I did a select, but did not fetch rows yet, or just a few rows. And I'm connecting to the same database on the top with SQL there. And I will show you what happens in the concurrent session when a select is running. This one is running because I selected a few rows, but not all the rows yet. If I check the $v views like $SQL, I can see that for this statement, I have one execution. And I know that this execution is currently running because I'm not at the end of fetch. End of fetch count is still 0. I fetched 3 rows. No, sorry, I fetched 5 rows in 3 fetches, and I displayed 3 of them. There are 2 of them in the SQL plus buffer, but the important thing is that the select is currently running. And I can update all rows in this table, which is something that you cannot do in a database that logs when it selects data. Usually, you cannot read something that is written at the same time. Here, you can, because Oracle did a select that does not log anything. So I update everything. So the commission, just adding 1 to it, and I can see my modification commission is 1. But here, 1 and 3 are 1, but here in the bottom in my transaction that started before, I still see the old value. At the top, because I change something, I can also query all versions, just to show you that Oracle records all changes, and this is how this is implemented in Behind. All changes are recorded. I can query the last value, but also the previous ones. But going back to my select, which is still currently running, now I will fetch a few additional rows. So here I fetched more rows, and they still have the old value because to be acid, to be consistent, because I started to show values before this update, I need to continue to show the values as of this point in time, or it will not be consistent. And that without locking anything, because I was able to change things. That means, so you can see that I fetch a few additional rows. No lock means that I can query, but also that I can do some maintenance. For example, I can reorganize the table, the move, reorganize the table, and I can do it online. I don't have to come on the weekend when the application is stopped to do that. I can even drop the table that someone is currently querying. I'm just showing that to show you that there are no locks at all. Of course, the idea is not to drop table in production, but you can see that my table was dropped, but the other one can still query it because it queries a consistent view from before. And that has nothing to do with the recycle bin. So that's why I purge it to show you. I can continue my select. So this illustrates the fact that when you read on when you query on the Oracle database, you just query a past image without blocking anybody else. And this is something that you cannot do on other databases. Most of other databases by default locks the rows when they read it to be able to serve consistent reads. So in select, Oracle is doing that. And the big advantage is that with Oracle, you can do your query, you can do your analytics on the operational database. Of course, if you build a data warehouse, you can separate the workload and do anything, but you don't need to. You can still query it. Okay, and last time I presented that, I've seen a tweet just before from Brent Ozar. So SQL Server, no lock everywhere. Because in SQL Server, when you select, you have to lock. And then if you don't want to lock, you can select with no lock. But then this is not consistent. This is dirty reads. So wrong results, basically. That was about select. For insert, again, all databases can do some inserts. What you have in Oracle is the direct path insert, which is fast load. When your application is inserting rows row by row, it has to update the indexes at the same time, do a lot of work. That is okay for OLTP, but if you load a big data warehouse, for example, or if you are just doing a migration or reorganization, then you want to do things in bulk. And with Oracle, also with other commercial databases, DB2, SQL Server, other commercial databases can do that, but in open source databases, Postgres, MySQL, you may not find this. And this is interesting for data warehouses, but also migrations, DBA stuff. For in-place update, I mentioned that especially to compare it with Postgres. So I mentioned that most of databases lock the rows when they read it, not Oracle and not Postgres. But Postgres, in order to be able to serve consistent reads without locking the rows, doesn't actually update the rows in place. An update is processed physically as a delete insert. I have a demo to show you something about it. So let me drop my table demo, and I create a table demo there on Oracle, and I connect to the schema, and I insert a few rows, 10,000 rows inserted there. I query the size of the table, so I have 12 megabytes for that. And I set an alias just to check some statistics when I will do the update. First, I can see the statistics, the redo size, 12 megabytes, which makes sense because everything goes in the redo. New values that are inserted goes to the redo to be able to be redone in case of crash. And I can check my table. So I have a flag there, just 1 byte. I reconnect just to reset the statistic for my session. I can see the state, and this is the update I'm doing. I update this flag. The value was no, and now the value is yes. Just changing 1 byte to another byte. Oracle does that in place, which means that my table is still the same size. You replace 1 byte by 1 byte. And if I check the redo generated, I have 1 megabyte of redo because there are some metadata about each change. But basically, that's the important metric. Especially when you compare to Postgres. So I will run the same in a Postgres database. I create a database that's fast in Postgres. You don't have the big dictionary like in Oracle. I create the same kind of table. I insert the same kind of rows. I check the size and I see something which is similar, 11 megabytes there. And I have something to check the amount of redo. We don't have statistics, but we can see an idea, and I just check the offset in the redo, in the wall. But this is the important thing. I update the flag from yes to no, the same. And now I query the size of the table. And sorry, that was not what I expected. Let me do it again. I missed something, or I was unlucky in my demo. Okay, yeah. I was lucky because the size of the database is very small, and there is some vacuum running in the background that I didn't disable. But what I wanted to show is that just changing 1 byte to another byte, here it is even the same value there. The size of the table has increased because the update is not done in place. It is a new version of the whole row that goes elsewhere, and then the whole row is duplicated. If I check, so that was the size of the wall, and if I check the size of the table, it has doubled. You can see 2 versions of the rows until we do some vacuum and something like that. So Postgres can do non-blocking reads, but with the price to pay for updates, where updates has to copy the whole thing. The thing is, Oracle put the old value in the undo, Postgres leaves the old value in the table and then has to go back to vacuum it. While I am in the demo screen, I will show you something else on the same table. So here in Postgres, updating again to n, and I will do an explain plan for a count star on a count of n from demo. And what I want to show you is that I have something that I expect, an index-only access. I expect that because I have an index on n and I count n, so I don't have to go to the table. The information from the index is sufficient. But I can see in the number of blocks that we can see there with buffers, I can see that I've read a lot of block because in Postgres, when it says index-only scan, it tries to do an index-only scan, but because of this multi-version in the table, it has to go to the table just to know if the changes were committed or not. And if I do the same on Oracle, update here, and I look at the execution plan there, I can see here that I'm doing an access on the index only, and I read only 34 blocks because an index on n is much smaller than the whole table. Okay, so that's what I wanted to show about index-only access and why is it important? Because basically you have two kinds of accesses. Either you are in OLTP and you just query to get a few rows to display to the screen, for example, and then an index access is okay. Index access is fast, but then you have to go to the rows in the table to show all the columns. And the cost of it is linear with the number of rows that you retrieve. There is a moment where if you want a lot of rows from a table, it's better to do a full scan. The full scan, the cost is always the same. You want one row or you want all rows, the full scan is the same because you read all the table. But you read the blocks only once and a lot of rows are coming from that. Basically, you have access to small amount of rows and then you access to the table with index or access to a big amount of rows and then you full scan. But when you are at the middle, this is where you have a problem because both are too expensive for what you want. And this is where in Oracle, you add more columns to the index so that you do an index-only access. You go to the index and you have everything in the index leaves, like covering indexes. So this is why it is interesting, and Postgres can do it, but in some cases, not if you had updates happening frequently in the table. Feature number 5. So this is a bit linked with what we have seen. In Oracle, you have no need to reorganize the table and no need to reorganize the indexes. It may happen that you do it because you purge a lot of data, but the normal activity in Oracle maintains the structures ready to be queried. It's like you ingest data and everything is made so that you can use the data immediately without reorganizing it, without moving into another database. This is why they do non-blocking selects, so that you can query it immediately. And this is also why it manages this undo, not like Postgres, where you have to vacuum to remove this old version of the rows from it. So that's quite important. You don't have to think about maintenance window to do those activities. Something that you find in Oracle and in most commercial databases, but you don't find them in open source databases, cursor sharing. When you run big queries, any queries, but it's more important with big queries, you just call with a SQL text, and this must be parsed and compiled as any language in IT. And commercial databases try to avoid to compile each time it is executed, the same as we like to compile a Java program once and then run it. But MySQL, Postgres do not share those compiled execution plan between sessions. So each session has to do the same thing, exactly like interpreted language, where each process has to compile it. This takes CPU, but also limits the possibilities that can be done by the optimizer. Oracle has a lot of transformation to do very clever things with very big statements on a large number of tables. And they add a lot more code at each version in the optimizer, and they can do that because it is not optimized for each execution. When it is optimized for each execution, you need to limit the amount of work that is done. And that's a big differentiator between open source databases and commercial databases. That doesn't mean that one is better than the other, but you have to think about it. If you already have an application parsing a lot or running very big queries generated by Hibernate, for example, or by a BI tool, you may think about the tools and you may think about the application before moving to a simpler database. Partitioning, I mentioned that because if you stay at the feature titles, you will see that all databases can do partitioning today. And then if you just have to checkbox about features, you can say, okay, partitioning, we have it in Oracle, but we have it also in MySQL, we have it in PostgreSQL. If you look at the features that are behind, you will see that because Oracle implemented partitioning a long time ago, Oracle 7, and new features came at each version, there are a lot of things that you do not find, at least yet, in other databases. Partition pruning is very important, and we can see them in others, but global indexes, for example, that's something you cannot find in Postgres yet. So you can partition on a key, but then you need to be sure that all accesses will access through this key. In Oracle, you can have an index that is partitioned on something completely different for another kind of access. Referential partitioning is also specific to Oracle, and the number of partition also. In Postgres, you can partition, but you will not create hundreds of partitions. In Oracle, you can create 1 million of partition. I do not recommend to be always at the limit. So 1 million, it's probably not a right recommendation, but you can have thousands, tens of thousands of partitions. So you can imagine like a NoSQL database where they hash partition to many, many, many shards. You can do the same in Oracle, for example. So for big data, that's a big difference. Feature number 8, and I'm looking at the time. Feature number 8, that's something I've not found in any other database, but maybe in any other software at all. I will run something to show you what I mean with that. Let's go there in my Oracle database. I do a show parameter optimizer just to show you that there are a lot of parameters that can be changed. And I will show you what is behind this optimizer feature enable. When I want to know the valid values, instead of looking at the doc, I just put a value that I know is a wrong value, and then it tells me invalid value, and it gives me the list of values possible. This means that I am in a 19C database, and I can run the optimizer as of any of this version. This is possible because Oracle development in the optimizer has, for any new feature, any bug fix, they do not change the code. They just put a flag so that they can use the old code or the new code. This is a big amount of work, and this is probably something that you cannot do in open source because the source code of the software is very hard to maintain with that. But the big advantage is that if I upgrade, say, from 11.2 to 19C, and if I encounter a problem with the optimizer, and usually this is where you encounter a problem because the optimizer is very complex and has new features, and then an execution plan changes, and then something that was fast is becoming slow. And of course, there are reasons for that. Can be bug, can be statistics, can be plenty of them, but you are in production, you tested most of the things, but there is something that was not seen during the tests. You are in production, you start after the migration to 19C, and something is slow. What you can do with Oracle immediately is set the optimizer as of the old version. And then everything is fine. You have the old execution plans, and you have time to try to understand what happened, and you are still supported. A lot of time, software vendors say, we are not certified for 19C, do not upgrade. But actually, you can upgrade and run the optimizer as of the previous version. And this is supported, which means running all security fixes from 19C, but the optimizer as of an old version. Of course, the goal is not to stay at this old version, just to understand what happens. And to explain you what is behind this feature, I show you a tool that is not from Oracle, but it's open source. And it's named Pathfinder. It was written by Mauro Pagano. And I run it just to show you on the screen what is behind. This script runs all those different flags. Behind the optimizer feature enable, there are some flags for all features. Like if you set 11G, it will set the flags so that the optimizer runs as of 11G. And this shows all the different flags that are behind. And there is a map between the version and those flags. So I will not let that continue for long. There are thousands of different possibilities there.
So
But
Frank, those flags are all related to the optimizer?
And those are all about the optimizer. Yeah, yeah,
Wow.
yeah.
And then do any other databases other than Oracle have anything like this that you can go back to the previous?
No, I've seen that Spanner, Google Spanner, started to do something like this, but they have just a few flags.
Okay.
I mean, the maintenance of the code is probably a nightmare. And this also explains why some bugs, which looks obvious, can take a few weeks or months to be fixed, because the code is complex. But
Right.
this is what ensures stability.
Yeah.
Let me check. There is a question. What is the name of the screen of the script? So the name, I will cancel it just to show you. It's Pathfinder, and I got it through Git. If I go to history, no, I have. Okay, just to show you. From Mauro Pagano GitHub. I will put that, if it's not in the slide, I will put that in the slide. So that's something I use. For example, I upgrade, we have a problem on a query, I set the optimizer feature enable to the previous one so that production can go, and then I isolate this query and I run this tool on this query, and this will tell me it's because of this fix or this feature. And the first thing I can do is move back the optimizer feature enable to the right version and just disable the feature that is a problem, and then give this information to Oracle support maybe, or just the name of the feature can give an idea about the fix. So optimizer feature enables, and that for critical database is really something that gives you more confidence in upgrades. Something that is a bit linked, because it's also the optimizer, hints. This is also another way to ensure plan stability, to avoid changes in the execution plan. And we have full control through hints. The idea is not to hint all your queries, but it can be a convenient workaround. And also, Oracle has a feature using those hints, SQL plan stability, the SQL plan baselines, where you can, for example, run in 11G and capture the execution plans from there and upgrade and get the optimizer feature enabled to the upgraded version, so 19C, for example, but still tell the optimizer to use the old plans. And when the optimizer finds a new plan that he thinks is better, he will just capture it, and then you can manually check it, or you have a job to check it if it's better or not. And then you ensure plan stability with that. And hints, again, most commercial databases have hints because in real life, in production, you sometimes need them even if you don't run them. Normally, SQL is a declarative language. You don't have to tell the optimizer how to go to access to the data. It's its job. But there are cases where the optimizer doesn't know exactly how your data is, and you may have to give some hints about it. Sorry, so that was about optimizer, and now something that is also very important for production, crash and media recovery. I cannot compare with all databases because I've been working a lot more on Oracle. What I know is that when an Oracle instance crashes for any reason, server problem, bug, anything, I restart the instance and I don't feel the need to check the database, like doing DBVs or an immediate backup to check that. Because I know that usually the instance recovery has no problem. Except if I have an explicit message in the alert log telling me that something is wrong or maybe corrupted, I do not check that. Most of my colleagues on other databases, if something crashes, they will check the database to be sure that there are no blocks that are corrupted or not. Oracle really put high priority in availability and avoiding corruptions in the data. And that's also the reason why a lot of companies have data in Oracle databases that are there for years and years and years. In the same area, Orman, recovery manager, it's not a backup manager. All databases have backup tools. Orman is a recovery manager, which means that in addition to doing the backups, it knows the backups that were done because it has a catalog, Orman repository, a catalog that can be in the control file or elsewhere. And then Oracle knows which backup has to be restored to get back the database. And that's something quite important. With other databases, you need to know, I need to restore the backup from that time. And for example, for Postgres, the wall from this time to this time. Recovery manager, the Orman knows that. And to show you that, I will show you even the recovery advisor. Let me just put that bigger. I show it to you because a lot of people do not know that Orman can go further than knowing where are the backups to recover. It can do everything autonomously, I would say. Here, I have a database with those data files. I have a PDB in it. And I will explicitly corrupt some files, checking the checksum there just to be sure that I change something. For all files with system in them, so the system tablespace, the most important ones, I just put some random bytes in the beginning of the file. Again, I don't do that in production. This is a lab just to play with recovery. And now, to do something in addition to that, I shut down a board which simulates a crash. So I crashed my instance and I've put some random bytes in important files. And if I want to start up it, of course, the system table spaces need to be opened. So I think I touched only the PDB system files. So the CDB should come up. And if the PDB is not in going to the open state immediately, I will open it, or maybe I did a save state. Let me check. I want to open all pluggable databases. And this is where it tells me I cannot open the system file because it needs media recovery. It encountered a corrupt block. So my PDB there for the moment is mounted, cannot be opened. This is production problem. And what I want to show you is that for those very simple kind of recovery, like just corruption, I can completely rely on Arman. First, I just run list failure, and it tells me I have seen that this data file is corrupt. Okay, then tell me what to do. Advise failure. I've just run the advise failure command, and it tells me you have several options. One that is automatic there, and this is what is recommended. And I can tell him repair failure. Just do it. And it shows me what it will run and ask me yes or no. The most important there is that I know that there are no data loss, which means that Herman knows how to recover from that without losing any transaction. Actually, so I will say yes, and we will see what it does. But it's transparent. It's automatic, but it's transparent. It tells me exactly what it does for that. And here I don't have a backup, but I have a standby database. And then it decided to get the data file from service, from the standby database, and get it back there automatically. And I start again, and I should be able to open the pluggable database now because the problem is fixed. Show PDBs opened. The only thing I did, except corrupting the data file, but that's not something we do. The only thing I did as a DBA there was list failure, advice failure, repair failure, just check that there are no data loss and that the solution is okay, and then get it like that. And what's interesting, it recovered only the data files that were corrupted. If you don't know how it works, and if you don't have this automation, you will probably restore the whole database, but you don't want to spend hours or days to restore terabytes if there is only one file to get back. So the advantage is that Recovery Manager knows exactly what has to be done and not restore all the database if only one file is corrupt. It can even recover a block, taking the block from the standby database, for example. So that's about Orman. Another feature I will miss if I quit Oracle, and people laugh about it, Oracle support. People laugh about it because we always have bad experience with software support because it always happens that we open a ticket and we have a support engineer and it has hundreds of tickets to handle, and then he asks some logs to understand what happened in your case, and you have the impression that it doesn't go in the right way. And that's right. When you have to open a SR, it can be long. But most of the time, you don't have to open OSR because Oracle support also write notes about problems encountered and notes that are validated by the development and with the solution. And most of the time when I encounter an issue, I just go to Oracle support and with the error message, which are really good, maybe not always understandable for us, but really good to focus at the problem. And with some tools, trace, and anything, I can find easily, most of the time, the my Oracle support note, which describes a solution or a fix, a patch to apply, or a workaround, a parameter to set, because there are all those parameters. And this is something that you find, actually, this is something that you don't find in open source databases. To run support, you need commercial software because they care about customers who pay for support. In open source database, you can have a lot of help from the community. And the community is really nice, but you don't have those notes. For example, if you go to Postgres mailing list or to Stack Overflow for any other database, you will have to read a lot of problem, answer, question, answer in order to find first if this matches your problem and if the solution is possible in your case. With Oracle support, after an SR happens, a fix happens, anything, you have a note which summarizes the thing so that you find it quickly. Let me check the questions. Most is not accessible if you only have a free Oracle account. Yeah, as I mentioned, you find this in commercial software because it costs a lot to run support, and you don't find it with open source, and you don't find it with free software, except that you don't have my Oracle support. But with a lot of free things in Oracle, you have the forums. For example, I use SQL CL. If you use a SQL developer, for example, you can have very fast answers in the forum. So even for free tools, they have people who will answer you. But of course, having notes and supports like that you pay for support. If you have only a free account, you don't pay for support and you don't pay for those people who write those notes. That's right. Feature number 13, and I'm checking the time, that's fine. DB time or wait events. When you have a performance issue, you need to know where is the problem. And that happened at the time of Oracle 7, where people at Oracle themselves wanted to know, to investigate on an issue, and the issue was not in CPU, and they didn't know where to look at, and they instrumented every system calls, which means every IO call, network call, and things like that, and those are the wait events. And this is something that other databases start to implement as well. In Postgres, you have also wait events, but not so many because it's just new. And this and also all the diagnostic tools are very useful if you have a problem, because you can really focus on where the problem is. With Oracle, I never read, for example, the buffer cache hit ratio, because it doesn't tell me where the problem is. It just gives some ideas and I have to think and guess and try. Here, with wait events and DB time, I know exactly if a query is long, what this query is doing. Is it spending time reading from disk block, from the index, or from the table? You have everything. You have AWR reports if you have the diagnostic pack. You have stats pack if you don't have this option, or in standard edition. You have TK-Prof in any edition. You can go very far. This is linked with the support. You have the notes, but you have also the tools that helps to diagnose an issue and then fix it. Upgrade and migration. That's also something that is important, because today, most, especially new companies, startup, choose the database. The developers choose the database. They look at the feature, they look at how it is easy to install, and they don't think that their database may be used for years and years and years, and one day you will have to upgrade, one day you will have to migrate. And Oracle has many possibilities to handle that in very large databases. Basically, you need to upgrade because the software evolves and there are fixes and there are new features. And one day you will need to bring the database to a new version. And upgrading in Oracle doesn't depend on the size of the database. I can upgrade a database in hundreds of terabytes. It will not touch the data. It will touch only the dictionary. So the time it takes does not depend on the size of the database, which is not the case in open source databases, for example. Most of the time, for example, in Postgres, most of the time people will recommend to do a dump, so the equivalent of a data pump when you upgrade. So you move all the data, and of course, this the time depends on the size of the database. You have a possibility to upgrade in place, which is good, except that, for example, when you upgrade, you lose all optimizer statistics. And then you have to analyze again. and think about a database in terabytes that you upgrade quite fast. But then before opening the application, just to be sure that you have good performance, you need to analyze all the tables. That can be very long. Sorry, so upgrades is something that is really advanced in Oracle, especially because Oracle is there for years and years and years, and there are a lot of databases in productions that are in 19C, I hope, today, and probably data entered there were entered in 8i or maybe Oracle 7, and it has been upgraded, upgraded, and upgraded. If you have a small database, you can export, import. If you have a big database, you want predictable downtime for those operations. Also, transportable table space is a way, if you have to move to another storage, another place, it's a way to do it fast because it's a physical move. I'm moving to the next feature and checking also the time just to be sure to have time for questions after. Let me just check if we have some questions. So this is done, I think, and this is, yeah, done, thanks. And
yeah, I think we're caught up on questions at the moment.
Yeah, perfect. Oracle is multi-platform, and that is also quite interesting because you are not forced to run on a platform. Even if today it's quite obvious that people start on Intel processors, it can change also. And Oracle has always been multi-platform, and to illustrate that, this is from Oracle 7. Install documentation, you can see that at that time, you were able to install Oracle on OS2, on NetWare, on many platforms, which were relevant at that time, not today. So this is why it's not possible today. But if things change on the platform, then Oracle is there. And that's quite interesting. For example, today, you can run Oracle on the cloud. You can choose the Oracle Cloud, where a lot of things are optimized for the Oracle database, but you can run on other cloud vendors, or you can run on premises. You can really choose where you run it. And that's interesting. And you can run on IBM Power, and you can run on Solaris with Spark processors in behind. You really have this choice. Any cloud provider, any NDNS, any relevant OS. And that's also important because when you start a big database today, probably you will have your data growing, and in 10 years, in 20 years, are you sure that you will use the same platform, Intel processors? That can change as well. Now back to features, more SQL features. Sorry. Like partitioning, you may have seen that other databases implement materialized views. If you use materialized views, then think about what you use with materialized views. Materialized views are not only views that are stored as a table. In Oracle, the materialized views can be updated in real time. You change something in the tables behind, and it is incrementally updated. And also, views are like indexes. You can query the tables. Think like in a data warehouse, you have a big fact table, and you build some aggregates. This you can do it with your application and build it as tables. But with your BI tool, you still continue to query the same big fact table, and the optimizer will realize that it can get the same result from smaller aggregates, and then we'll do that. This is where we go to this optimizer, which is very complex and can do a lot of things. If you go to another database, you will probably have to maintain your materialized views yourself. So again, if you compare the feature, just look at what those features are doing. I've put many features there in this slide. Those are features that you don't use every day, but if one day in your career you need them, you will be very happy to find them. Flashback features are like, oops, I made a mistake, let me roll back that. And I'm not talking about inserting or updating rows because you can roll back a transaction. I'm talking about dropping a table. And I will give you an example. I think I used only once flashback before drop in production, a lot in labs, because in labs you play or in test databases, but in critical production only once. And we did something with a customer, and we had to partition a table, and he told me that we can do it because it's not used, and we can even drop it and recreate it because the BI job, the data warehouse load ETL, will reload all the data. And you have ways to do it online with Oracle, DBMS redefinition, but the customer told me, you don't need to think about that, just drop and create it partitions. And I did it, and he has run the ETL, but then I've seen that the number of rows was not exactly the same, and the customer was quite worried because he realized that there were one table where the ETL was incremental, and then a lot of data was lost, and he was worried because the guy managing the backup was not there and anything, and I just asked him, but do we just need to get the table back? And they said, yes, but the guy from the backup team is not there. Just wait. Flashback table to before drop, and it was back. So a small, simple feature to use. If you know that is there, you use it, and it saves your at least your day, but maybe more. If you don't know this feature, you don't use it, of course. So it's good to know those features. And when they are there, it saves a lot of money as well. So you pay for features that maybe you use once, but you use once when it is critical.
Are these do these features, do you need to actually need to enable them, or are most of them a default?
Most of them are default for the dropped table. The flashback database, that's something that you enable, and it can be a good idea to enable it, or at least flashback database. This is more flashback the whole database. So usually you don't do that for the production. You can do that on the standby, but you can do that. For example, you have an application release. Yeah, I have also an example about that. An application release, they needed to update a few rows in the user table where the application passwords were, and they just forgot a where clause in it, which updated everything in the e-commerce application, and then nobody was able to log in. Wow. Restoring a backup of a big database can take a few hours. But there, because we were in flashback mode, flashback database was very fast because it doesn't restore anything. It just undoes the latest changes. So that's again something that is that protects the database.
Very cool.
And also log miner, you can, if for example someone tells you in the application, we think we have a bug because some data we expected to have value 42 and we have value 5. And something happened maybe last month. If you still have the archive log from last month, you can find exactly which transaction does what with log miner. So many tools that are there to help. Things like flashback database, I think you don't find that in other databases. So of course, you can emulate it with snapshots on the storage level. Talking about protection of database, DataGuard, and I will not run the demo for that, but I will just explain sorry that DataGuard is a bit more than what we think it is. All started with physical standby, which means that in addition to the operational database and backups and archive logs to be able to recover from the backups, you have a standby database running in recovery mode so that if you need, to switch to it. You don't have to restore and recover. All was already done. But today, DataGuard goes further. So we kept this idea that DataGuard is only for DR, big disaster. You have a fire or flood in the data center, and then you have to fail over to another site. DataGuard, so many databases can do this physical standby thing. But first, DataGuard can run in sync, which means that every commit guarantees that the commit has been shipped to the other site. Of course, if the latency is okay for that. And that's very important because you know that at the time of failover, you do not lose any transaction. That's important. And the second thing is that also, if you are in sync, you know that you don't lose any transaction, and then maybe this decision can be automated. Of course, if there is a risk of data loss, you probably want a manual decision. Do we wait that the primary site is up again, or do we fail over with the risk of losing data? But if everything is in sync, you can automate that. And this is what FSFO, faster failover, is. You have just a little application connected to both databases, which detects a problem and then can automate the failover to it. And then you can do high availability with, if you can accept no data loss, of course, and if you can accept a few minutes for a failover, that can be also a solution. And also, I mentioned there snapshot standby. This is very useful because this standby database, you can use it. For example, you have a bug in production and you have a bug fix for your application, but you want to test it on a copy of the production. If you have a standby database, you can just switch it to a snapshot standby, which you can open like a normal database, test your fix, and then when it is okay, you just switch back to a physical standby, and it will just apply the logs that were shipped during that time. I have also some customers using a snapshot standby just to get a daily copy from their production, which means that in the morning they open it in snapshot standby and people work on it to test things or anything, and during the night it gets the apply from the log that were shipped. Let me check the time. Yeah. So at first I listed 19 features just because we were in Oracle 19, so no big reason with that. And finally, there are too many features so that for the slide 19, I've put a lot of different features. And pick the one you want. You may not need all features, but maybe one of them. For example, if you don't want to come on the weekend to do maintenance operations, in Oracle, you have a lot of online operations that you don't find for most of them in open source databases. So it's okay, you can move to open source database, but just know that you will need more DBAs, more overtime, and more things to manage, probably. There are some features that are probably not known enough. For example, connection manager. You have a proxy in front of a database or a cluster or a database on the standby. And the application just connects to the connection manager, and then the connection manager knows where the service is running. So this allows transparent failover, transparent to the application. Many features like EBR, which is a feature where I don't really like the name, it's just versioning the code. If you code in PL SQL, you can do continuous deployment without interruption for the application. You just deploy a new version and then switch sessions to the new versions. There are a lot of them. The RCP is also something that that comes back to be used now with microservices. The RCP is a connection pool. So you may think that you don't need a connection pool because you have it in the application servers. But today, with microservices, we see a lot of application servers, like 20 or 100 of them, and if each of them have a connection pool, and then you have thousands of connections in your database, and with the RCP, you can pull that in the database because this is shared, so you can limit the risk of overloading the CPU because you control the number of sessions there. I move on the next slide, and we can go back if there are questions about other features. But after showing all those features, with this idea that people today are looking at other databases, maybe not for everything, but for example, you have a new project. Do you want to put it on Oracle or on an open source database because it looks cheaper, or because you like the open source idea or anything? The problem, I've seen many IT managers telling their people, do not use Oracle specific features because one day, if we want to move, we don't want to be locked in with Oracle. And this is, in my opinion, a very bad choice, because in this case, what happens is that they pay for Oracle, which is expensive because it has a lot of features, and they don't use those features. So they lose on both sides. Either you move to a cheaper database, and then you have less features and you have to do with it more code in the application, more people in the DBA team, for example, or you stay with Oracle and then use the features because they save you time and money. Use the online possibilities, you use PL SQL because it saves time to deploy the application, and you have less performance problem and anything. The thing is, if you think you may want to move out of Oracle in 5 years, for example, just use all the features, just document them so that you know that if for any reason you have to reduce the cost and not use commercial databases anymore, you know exactly what you have to replace. For example, let's take something. You use, let's say, the DRCP, the connection pool in the database. It's easy to set up. You have it, and then you can have many applications with microservices. If you move to a database without it, you have to think about the architecture of the application. And this has a cost, but if you know the cost, then you can balance it. So my recommendation is know which features you use and that are specific to Oracle. And then if one day you look at other solution, you know the cost of it. And the thing that happened also is that when you know exactly what it costs you to move out, you are in a very good position to negotiate with Oracle sales. You know, salespeople, if they think that you are locked in, they can do the price they want, you are locked in. If you come to them and tell them, we can stay if it's not too expensive, or we can move out, and we know that moving out will be a project taking a few months, a few people, and we know the price. And then you can negotiate the price, and probably you will have a good price to stay with Oracle and use all those features and without this migration project. So the idea is use the feature, especially those who saves you time and money, just know them. Checking the question there. Does Postgres has feature like snapshot standby? No, you don't have that. You can emulate that with snapshots on the storage. But those are the kind of thing where in Oracle it is just one command. And for example, for the customer using snapshot standby for the daily copy, it's just a script. You do it. You have one day to do it and test it, and it works. If you want to do the same with the storage, that will be specific to your SAN. It will be specific to your database. So you can do the same, but it takes you time, code, you have to validate anything. So everything is possible, but you have a cost. What Oracle brings is those features that comes with it directly. And another question, can I use data pump to export the data from CDBs, including all the PDBs in one command and not individually? No, data pump works at PDB level. So you do it for each PDB. Usually when you do data pump, you do a logical export. And this concerns an application, a set of schemas, and the CDB is more like the server, like a host for the databases in it. So probably you don't want to do something logical in the CDB level. Okay, then before taking more questions, my core message here is what I mentioned. First, so that you know the features you use in Oracle. Probably you didn't know that you benefit from non-blocking selects. If you move to another database, think about it. You may have some queries, reports, analytics that you will not be able to run anymore on the operational database. That means that you will have to replicate data in another database, like a data warehouse, and run your report there. And this is a valid solution, but just it has a cost and it is a project. And as I mentioned, do not stop at the titles when you compare features. Partitioning does not mean the same thing in all databases. Do not stop at popular buzz. The most interesting features are behind select, insert, update, not the new fancy things. And do not stop at development features. And that's hard today because architects and developers are usually choosing the database and without thinking that someone will have to operate it, that in 10 years you may have to migrate it, and all those operations you rely on them. And in order to take questions, and if there are questions about other feature, I'm showing here something that has been done by Ricardo Gonzalez, who is a product manager at Oracle, and they did something very nice to show many features, just a few because there are a lot of features, and to show that those features came through version. And what is special with Oracle database is that this database has 40 years, I think. Huh? So many features are very old. And I mentioned the first feature I love is non-blocking select. And you see where non-blocking queries happened, Oracle version 3, the second version, 1983. So even if today other databases are doing that, for example, in SQL Server, you can run with MVCC, something where you can do non-blocking selects. It's not the default. There are some limitations because it's just quite new. It has a few years, but it's new when you compare with that. Is there any question? And if not, I can mention other features there, but probably better if we have some questions.
While we're waiting for questions from the audience, there is one from, there actually is a question to panelists. Its question is FSFO or ADG or Global Data Services available in any other database?
So FSFO, I don't think so. The important thing behind FSFO, more than the automation, is the fact that we can run in sync, be ensured that we have no data loss. Automating a failover is quite easy. You just activate the standby. But when you do that, if you have the risk of losing transaction, then this is a problem, except some very special databases where you can accept that. And I can also mention something. It's not only about losing transaction, the problem. The problem is usually knowing what you have lost. For example, you have, if you have a web application and people can update data, you cannot send an email to all your users telling them something happened, you should check what you have done in the last hour. If it's an application, in-house application used by the accounting department, and those are people in the same open space, then you can tell them, please check what you have done 1 hour before. But losing data is something, but knowing exactly what you have to re-enter, that's different. You have jobs ingesting some data. Which job do you need to run again? And are you sure that the jobs that you run again are okay? They will not add duplicates? That's difficult. So in the equivalence of features, in this example, FSFO, with Oracle, you really have the guarantee that it can be automated because you do not lose any transaction. So difficult to find in other databases. Of course, I don't know all features of other databases, and then they evolve, but not so easy for sure. About Active Data Guard, yeah, there are databases where you can read also from it, but Active Data Guard has more things that, like in today's version, you can also update on the standby. The goal is not to do a lot of updates, but what we see with Active Data Guard, there are some applications read-only, so they can run on the standby, but they just have to do an update when they log. And for this reason, they cannot run on a read-only database. And that's something that you can do today when a standby can accept a few DML that are redirected to the primary. Let me check one question. What is the best feature in Oracle not found in other databases? I would say non-blocking queries. And I mean, even if you find that in other databases, you find them with drawbacks. I mentioned that you can do non-blocking queries in Postgres, but the price you pay is that you have to vacuum your tables in behind, and that has a cost. So probably for me, the best feature is non-blocking queries, and it's a very old feature. And it's more than this feature itself. I think it's a philosophy with the Oracle database, like being able to query on the same database. When Oracle introduced in-memory, for example, which is probably something in 12c, I don't know if it's mentioned. Yeah, the in-memory column store there, the idea is exactly that one. You have analytics, and you don't need to build another database and replicate to it. You can do your analytics in the operational database because you have an in-memory column store in addition to the row store. So the non-blocking reads, is more a philosophy. Oracle database maintains data for the whole life cycle. You don't have to build a database to ingest data and then move data to a database to query it. Everything is the same.
So the non-blocking queries, so to you, it's what you just said, which is this ability to kind of not have separate phases. But is it the performance that non-blocking gives you, or just makes you don't have to think about it? It just makes the programming the SQL easier.
So of course, there is an overhead everywhere. The fact is, because it is a very old feature, all the side effects have been improved.
I see.
When working in Oracle 7 or 8i, we all remember that we had to size the rollback segments. before the undo table spaces that maybe are mentioned there or not.
Right.
And the non-blocking queries without the bloat that you find in Postgres add a severe drawback that you add to manage this undo. But today this is quite automated, and then the overhead is very limited.
Okay. So it's sort of a good feature, and then it's sort of just incrementally over the years has continued to get more and more transparent.
Yeah, this is also where, when you compare features, it's interesting to see that those features are very mature because they appeared years ago, and for others it's new. New doesn't mean that it's bad. New can be also good because you don't have all this history of compatibility and anything. But of course, things that are old have been improved a lot, as they will be improved elsewhere. For example, SQL Server has implemented the MVCC, but it's not default. There are limitations, so you can use it, but there are probably more limitations than in Oracle where it comes like that.
I see. Very good. So thank you, Frank. We've had a bunch of questions. We're about quarter after the hour, 20 after the hour. Questions seem to be dropping off. So any final thoughts? I actually don't have any additional specific question. Well, actually, I do have one question.
Yeah.
So I know that I follow you on Twitter, and quite often I've seen you, talk about backups in other databases like Postgres. Is there anything similar to RMAN, or what? How do folks like freeze the state of the database in Postgres, or some of these open source databases? Is there anything equivalent to RMAN?
There are things equivalent to do the backup, but not with this recovery catalog. And there is also something, for example, with Oracle, you can do the backup with RMAN. You can also do it outside of RMAN, just copying the files. But then you need to be in backup mode to avoid fractured blocks. I will not go into the detail. And then you have additional logging. And usually you don't need that in Oracle because you use RMAN, and RMAN knows how the blocks are used. In Postgres, it's like being in this backup mode always. Like you generate more redo that are called walls, just because when you update even 1 byte in a block, in a page, you have a full login sometimes for the whole block to avoid fractured blocks. So those are things that are in behind, working the same, but more optimized in Oracle. And there is also a reason. It's not because open source is bad or simpler or anything. If you are building an open source software, you must keep it simple so that people can contribute. And probably the code of Oracle cannot be maintained by a community because it's probably too complex because of all those features, optimization through the years. So this is not because a product is bad or not, it's the philosophy. Open source does simple things right, maintained by the community. Commercial databases can do very complex things because it's commercial. People are paying for that and people maintaining that.
Yeah, that's interesting because there's an open source project that is very popular. I won't say the name, but I was pretty intimately involved with it for several years. And the overall maintainer, that was his philosophy. And I think, frankly, it was a good one, which is you would a certain level of complexity that he didn't think he could manage, or if the person developing that software left, and then the community got dependent on it, and then who's going to maintain it? And so I had developers working on things that were actually very good, but they didn't get in because I think to that very issue. And there's really nothing, there's nothing wrong with that, because simplicity in software has its own set of benefits. And so, that's fine. But, I think what Oracle brings to the table is this ability to solve some really hard problems. And and give you the power when you need it.
Yeah, with open source, you have always the risk that the projects stop as well. There are forks like MySQL, MariaDB. Postgres has a very strong community, but for example, recently, EDB is having more and more power on Postgres, and then people ask. So always be prepared that one day you may have to move. With Oracle, you may want to move one day, but for sure there are Oracle customers that will always be there, and this database will always be there.
Yeah.
And you have this guarantee. And also because it's multi-platform, and this is also why at the time of the mainframe, there were some databases migrated to Unix and then to Linux and everything. So in the long term, Oracle will still be there with those features. In open source, you go to simplicity, but you may have to change one day.
That's right. Very good. All right. So any final thoughts before we, and then would you mind sharing the screen back to me, if you don't mind?
Yeah, stop sharing there.
And then I'll put up there we go. All right. It's a little clunky, but so any final thoughts or comments before we sign off here, Frank?
No, just there were a question about where you can get this diagram. I've put the link, or you can follow Ricardo Gonzalez on Twitter, and he did some very interesting things beyond his product itself. And the diagram with all the features is quite interesting. Nothing else. I'm really happy to be there and talking on Ask Tom.
Well, thank you very much. You've done this actually Frank did this for an internal Oracle audience about 5 weeks ago. And he was kind enough to come back and give it to the external audience. And we're very, very grateful. And every time I listen to it, I learn several new things. So again, thank you very much, Frank. Just so everyone knows, this will be, we will take this broadcast video and we will put it up on the Oracle Developers YouTube site. That's going to take a couple of days. I'm still a little bit new. I took over from Tammy about 6 weeks ago. So my goal is to get it up there next week, and subscribe to the Database Cloud Service Office Hours sessions if you haven't already, and you will then get an email when that's available, and we'll make sure that we put the Frank slides in there as well. And with that, we are working on scheduling the next Database Cloud Service Office Hours again. So please subscribe to that Ask Tom channel, and you'll hear about it and more great content. So with that, thanks everyone for attending. Thanks again to Frank, and we'll see you guys next time. Take care. Thank you.
Bye.